Hi there, Pete Mattock here with my latest installment on understanding maths hacks. The internet is awash with maths tips and tricks and hacks that pupils will pick up on. But if anybody knows anything about me and what I believe in maths education, I think students should not only be able to do the math, but they should understand the why behind the math. And today, the hack we're going to look at is testing for divisibility by 8. And in particular, testing very big numbers for divisibility by 8. So for this number as an example, 27,163,152. Is this a multiple of 8 or not? Can this number be divided by 8? Now, of course, we could actually just divide it by 8. And if we're very, very good with things like the division algorithm, short or long division algorithm, we could just divide that by 8. But we don't need to divide it by 8 to know if it is divisible by 8. And in fact, we only need to look at the last 3 digits, because we know already that 1,000 is a multiple of 8. And if you didn't know that, then you can take it from me. 1,000 is a multiple of 8, which means any number that's in the 1,000 times table is automatically divisible by 8. So if these 3 digits were zeros, I could guarantee that number is in the 8 times table because it's a multiple of 1,000. So I just need to look at these last 3 digits. And what you may notice here is I've written down the numbers in the 4 times table less than 100, but I've split them into 2 groups. I've split them into the odd group. Now, these are obviously not odd numbers because they're in the 4 times table. They are the multiples of 4 by an odd number. So 1 times 4, 3 times 4, 5 times 4, 7 times 4, and so on. They're what you get when you multiply 4 by an odd number. And similarly over here, you get the numbers that you get when you multiply 4 by an even number. So 2 times 4, 4 times 6 times 4, 8 times 4. And those are obviously also the multiples of 8, because if you do 4 times an even number, you're doing 8 times a number. 2 times 4 is 8. So you're doing 8 times some number. And what it turns out is, if you look at this digit here, the hundreds digit, remember, we don't need to look at any of these. If you look at the hundreds digit, if that is odd, then what you're doing is, if you're looking at to see if this number, the number made by these last 2 digits, is in these odd multiples of 4. And similarly, if this number is even, then what you need to do is look for these last 2 digits and see if that number is in the even multiples of 4. So given that this number 1 is an odd number, I need to look in here and see, right, is 52 in this list? And if it is, then that whole number is a multiple of 8. And you can see 52 is in this list right there. So because this is odd, and this is in the odd multiples of 4 list, turns out that means this number is always a completely multiple of 8. It's divisible by 8. And if we were to change that so that this was, say, 4, then I'd be looking at this list and I'd be saying, right, well, 52 is not in this list. So 27,163,152 is not a multiple of 8. And that's the trick. It's a nice trick. It means that you've got an easy way just by checking on the last 2 digits in whichever list of these 2 lists you're looking at to see if the whole number is in the 8 times table. But why does it work? Well, it works partly because of when these numbers, the hundreds, are in the 8 times table, and partly because these numbers are multiples of 8, but these numbers are the multiples of 4 that aren't multiples of 8. And when you look at your hundreds, and which hundreds are multiple of 8, it's the even hundreds. It's 200, 400, 600, 800. And so if this is an even 100, 200, 400, 600, 800, because that's a multiple of 8, then we also need the last 2 digits to be a multiple of 8. Because if you take a multiple of 8 and add it to another multiple of 8, you're going to end up with a multiple of 8. And obviously all of this, without these 3 digits there, if those 3 digits were zeros, would automatically be multiples of 8. So you'd have a multiple of 8, add a multiple of 8, add a multiple of 8, and you'd end up with a multiple of 8, something that is divisible by 8. But when this is not a multiple of 8, then we need this to not be a multiple of 8 as well. but both to be in the 4 times table. Now, this 100 is automatically in the 4 times table, so similarly to the 1,000, any number that's in 100, any number of hundreds, any number that's in the 100 times table is automatically in the 4 times table. So if this number is also in the 4 times table but not in the 8 times table, it makes the whole number a multiple of 8. And we can actually prove that algebraically as well. If we look at these numbers, 4, 12, 20, 28, these form a linear sequence. They go up in 8s. Their nth term is 8n minus 4. And then if we look at the hundreds, and we're looking for the odd hundreds here, so 100, 300, 500, 700, their nth term is 100 times 2n minus 1. 2n minus 1 gives you the odd numbers, and when you multiply that by 100, you get the odd 100, so 100, 300, 500, 700, and so on. And then what happens if you add these two together, doing a little bit of expansion, you get 208n minus 104. Now, it turns out that number is in the 8 times table. 208 is obviously in the 8 times table, because 200 is and 8 is, so that's 8, and it's actually 8 times 26. But this number, you can see here, if we were to add another 8 to 96, 104 would also be in the 8 times table. In fact, it would be the 13th number in the 8 times table. Now, I know this isn't fully factorized for those purists out there, but what I'm demonstrating here is that this number will always be a multiple of 8. And so what we have is the maths behind that trick that says, if this is an odd 100, and this is a multiple of 4 that isn't a multiple of 8, which is described by the sequence 8n minus 4. When you add those numbers together to create like 152, you're always going to end up in the 8 times table. And so the trick there, if that's an odd 100, we look for the odd multiples of 4, and if it's an even 100, we look for the even multiples of 4. But that's why the trick works. So that was my video on understanding the math hack behind finding out if a big number is divisible by 8. If you've got any hacks that you've encountered or your students have encountered and you're not sure as to the maths behind them and why they work, please do let me know. I'd love to explore it and see if I can show you why they work.